All right, so once we reach that 1 second, the next kind of the progression of this Big Bang or the creation of the universe. So from that one initial second to about 300,000 years from the Big Bang, the universe finally does cool off enough for atoms to form. The first elements to form in the early universe were hydrogen and helium. So our stars, the sun, any stars and other galaxies, all are formed from the fusion of hydrogen and helium. So those are the first two atoms or elements to form in the universe. And then during the first 1 billion years of the universe existence, those hydrogen helium atoms, like I just mentioned, fuse together, which is another fancy way to say combine, to start to form nebulas, which are the birthplaces of stars. So once helium and hydrogen started to form or fuse together, we started to get our first stars, which then ultimately began to form our first galaxies. So moving on, and then now over the course of the next 14 billion years or so, stars die, stars are born, just like humans, pets, animals, all sorts of stuff. There is a life cycle. So when stars die, depending on the mass of the star, they die in different ways. Super massive stars, when they eventually run out of fuel and they die, they end in these spectacular events called supernovas, which we're going to learn about next week. And when those supernovas happen, they produce so much energy in their death that they cause all sorts of dust and particles and other elements to stir around in the universe. And when those dust particles, elements are stirred around, they clump together and they form new nebulas, which form galaxies and stars. So it is happening constantly in our universe. And then about 4.5 billion years ago, the Earth that we call home is formed. So at some point, the sun, before it became the sun, was in a solar nebula, which was put into motion from a nearby supernova that caused gases and dust to clump together, eventually forming our sun. So you can kind of see the evolution of our solar system here. We have the birth or the nebula of our sun. It spewed materials outwards. The heavier elements are metals. They were pulled in by the sun's gravitational force. So that's why our inner planets are considered rocky planets. And then the lighter gases escaped the sun's pull. They were eventually pulled back into the solar system, but that's why we have Jupiter and Saturn as our gas giants, because they are predominantly made of light gaseous elements. So over the past 4.5 billion years, our solar system has become what it is today. And we see from images taken by astronauts and by NASA and other international space organizations. So why do we believe in this Big Bang Theory? So there's three key pieces of evidence to support the Big Bang Theory. Those three pieces are the Doppler effect, more so about this idea of redshifting, cosmic background radiation, and these objects known as quasars. So I'm not going to watch this video because it's about 2.5 minutes long, but on Google Classroom, I will upload this PowerPoint, and you can watch this video from an episode of the Big Bang Theory where Sheldon dresses up as the Doppler effect for his Halloween costume. It's a pretty funny little twist on the Doppler effect. So the Doppler effect. Last year in physical science, you learned about wavelengths, sound and light waves. So the visible spectrum, or visible light spectrum, is shown by all these colors, from our purples to our reds and everything in between. The wavelengths are up here. So on your electromagnetic spectrum, you have gamma rays as the shortest wavelength, and then we have our radio waves as our longer wavelengths. Colors give off wavelengths. So if you've ever stood outside and listened to a police car drive by, or an ambulance drive by, or a fire truck drive by, you may have experienced, or you have experienced, a Doppler effect. So as that vehicle is approaching you, the siren pitch gets higher, and then as it moves away,